Section 11.8, welcome! Multiplying and dividing radicals, and in this video we're going to be focusing on rationalizing the denominator. So it's a sort of division technique, and well actually it's not necessarily a technique, it's getting rid of those square roots that we might have in a denominator. And if we remember right from when we were playing around with fractions at the beginning of the year, I talked a lot about fractions being just gigantic division problems that are just simplified and not necessarily solved. So this is our second video in this section, and let's get started. Rationalizing the denominator. So rational numbers are those square root numbers, and if you notice in this sort of problem, we have essentially the square root of 7 over the square root of 2. And the square root of 2 is bad to have in a denominator. It means it's not quite in simplest form. It's not as simple as it can get. And while this looks okay as of right now, and it looks pretty simple, and then when I finish this up, it might not look as simple, or maybe it will, I'm not sure. Biggest thing is we cannot have a square root in the denominator. It's just a rule in math. It's not in simplest form. It is if there's a square root in the denominator. So the way we can take care of this is by essentially multiplying by a gigantic 1. And it is essentially a fun little simplification technique that we've used in the past when we're finding equivalent fractions. So essentially all we're doing is finding an equivalent fraction. And check out this 1 that I'm going to multiply by. If we notice, the square root of 2 is in our denominator, so the only thing that can get rid of that simply is by multiplying that denominator by the square root of 2. And if I do that on the bottom, I need to do that same work on the top, so I'm going to multiply by the square root of 2 on the top as well. So the square root of 2 times 2 is on the bottom, and the square root of 7 times 2 is on the top. So our answer for this problem is going to be the square root of 14 over square root of 2 times 2 is equal to square root of 4, and the square root of 4 every time we do it should be 2. So square root of 14 over 2 is our final answer for this problem. And that is with that denominator simplified. If we notice now, there is no square root in that denominator, and that is a good thing. Let's try another problem with rationalizing the denominator. We have the square root of 7 divided by the square root of 8n. Now we can do this one of two ways. If we wanted to, we could simplify this first. So essentially say, okay, there is a 4 and a 2 in here. I'm going to take a 4 out, and so the new denominator would be 2 square root 2n. So we could do it like that. Or we can just rationalize this denominator by having square root 8n and maybe doing this sort of simplification later. And that is the method I'm going to show you, just because I don't like getting bogged down with simplifying things and having extra stuff around that makes me all confused. So my 1 that I'm going to multiply by on the top and the bottom is 8n. 8n. So essentially what we'll have is the square root of 7 times the square root of 8n divided by the square root of 8n times 8n. Square root of 8n times 8n, that'll come out as essentially those two pairs can hold hands and they can leave this situation, be freed from it, and we just get 8n. So essentially on the top, if we look at this, 7 times 8 is 56n. So we have the square root of 56n over 8n. Now you might think, I'm totally finished, I'm done. But like I said before, square root of 8n wasn't simplified. That means most likely the square root of 56n, because it has an 8n inside of it, is not simplified. So let's think 56. Let's think factors of 56. 56. What are some factors of 56? There's a 4 inside of 56, and there's a 14. And while 14 isn't a square number, 4 sure is. So we could rewrite this as 4 times 14 times n in our square root symbol, and we have over 8n. So now this 4 will come out. It'll pop right out as a 2, and so we have 2 square root 14n over 8n. And we are not yet finished. We're not yet finished because we can simplify that as saying, and I'll move over here. We can simplify that as saying the square root of 14n over 4n, because essentially we can divide by 2. Oops, sorry, that wasn't the right number. I didn't want to write that. We can divide by 2 and get 1 out of there, and divide 8 by 2 and get 4. So we can simplify that, and we have the square root of 14n divided by 4n. So there is our final answer to the square root of 7. Square root of 7 divided by 8n, we get square root of 14n over 4n. And that original equation, yes, it does look more simplified, but it has a square root in the denominator, so it is not. Let's practice this a couple of more times. We have the square root of 13 times the square root of 5. Our 1 that we're going to multiply by is the square root of 5. On the top and the bottom, we are rationalizing that denominator. So what we get on the top is essentially the square root of 13 times 5 over the square root of 5 times 5. So that is equal to the square root of 65 over the square root of 25. Square root of 25, if we did that math, we get 5 out of there. And 65, let's think factors of 65. We might need to do a little bit of math. We get 1, 3, or not 1, 3, 1, 5, 13, and 65. No other factors. So that's as simplified as it can get, and if we notice, there are no squared numbers in there, so the square root of 65 is as low as it can go. So we get the square root of 65 over 5 for our final answer for the square root of 13 over 5, over the square root of 5. Last problem, square root of 7a over the square root of 12. So this is similar to the other problem where we have the square root of 12 and it has a simplification in there that we need to do. So we are going to need to pay attention to that after we do a little bit of our rationalizing of the denominator. You're probably shouting out right now, what is the number that we are going to be multiplying the top and the bottom by? And you should be screaming square root of 12. We're going to multiply the top by the square root of 12 and the bottom by the square root of 12. And if we do that, on the top, we'll get the square root of 84a, and on the bottom we're going to have the square root of 144. Square root of 144 is 12, and 84, let's think factors of 84. We can definitely put a 4 in there, and we can definitely put a 21. So 4 times 21 is what we are going to simplify by, because 21 doesn't have any squared factors, but 4 does. 4 is a squared number. So we can rewrite this as 4 times 21 times a over 12, because we did that math already. That's kind of cool. So 4 times 21 times 12, 4 will come out and become a 2. So we get 2 square root 12a over 12. Last little bit of simplification. If we notice, we have a 2 out in here and a 2 here. So essentially the 2 will become a 1 and the 12 will become a 6. So we get the square root of, square root of 21a over 6 for our final answer. Play around with this whole concept of rationalizing the denominator. If you have any questions, please be sure to ask. I would be happy to answer any questions you may have. As always, you may email, text, or call me up at any point in time. Thanks so much, and I will talk to you later. Bye.